Hello everyone. Today we are going to start lecture 03 of class 8 mathematics chapter number 5, which is data handling. In this particular lecture we are going to see how do we construct a discrete frequency distribution and how do we construct a grouped frequency distribution. That is, how do we form the tabular forms and how do we represent these frequencies on a table. So there are two kinds of frequency distributions, so let us see both of them with the help of some questions. So this question says that given below are the ages of 25 students of class 8 in a school, prepare a discrete frequency distribution. Now we all know for preparing a frequency distribution we have to count how many data points are there and how many times they are repeated. That is the frequency. So this is our raw data. What we have to do is we have to arrange all of this data in the form of a table. Okay, either in the ascending order or in the descending order, and then we have to count them. So let me show you that how do we construct a frequency distribution. For this particular data, the frequency distribution looks like this, where we have formed a table. This table has three columns, right? First column is the age, that is your data, that is the variate. Second column is the tally marks. Why tally marks are used? Because when we start counting a data point, it will be a bit cumbersome. Okay, so suppose we have counted 16, we will put one mark, then second, then third. And what is frequency? We'll count at the end that how many tally marks are there, then that will be the frequency. That is the number of times that the data point is repeated, right? So we can start writing the table. So let us start constructing the table. So first of all, we can see that after seeing the data, we see that 14 is the smallest data point. So we can write 14 in the table. Next one is 15. Then we can see that there is 16 and the last one is 17. So there are only four columns of three columns and four rows to be made in a row. This is the title row and this is the total. Okay, so we have to form only four rows because there are four different kinds of observations of ages, right? Now let us start counting 14. So we have 1. Then, so you can put 1 tally mark. After that we have second, so you can put second tally mark. 3 and 4. So we have 14 repeated 4 times. So we can write frequency as 4. Now let us start counting 15. 1, 2, 3, 4, 5, 6, 7, 8. What am I doing in this question is exactly why we are using tally marks. Okay. 5, 6, 7, 8. Now every time you encounter 15, you should write a tally mark. Okay. Because doing this will create a rough impression and your question paper answer sheet may look very untidy, right? So you should always use tally marks so as to avoid these type of marks, right? Now let us count 16. So 1, 2, okay, then 3, then we have 4, 5, 4 and 5, right? Then we have 6, 7, 8, 9, 10, 9 and 10. So we have 15 repeated 8 times, 16 repeated 10 times. Okay. So since these were the data of 25 students, so we have got 10 plus 8, 18 plus 4, 22. So we should have 17 only 3 times. Let us see. So 1, 2 and 3. So we have 17 3 times. So we have the frequency 3. Now what this total means? Now you can cross check that your frequency, that you did not made any mistake in the counting. So this total should be 25 because these data points are of 25 students. So we can see 4 plus 8, 12 plus 10, 22 plus 3, 25. So this is how we have constructed a table or a frequency distribution for ungrouped data. Okay. Frequency distribution for ungrouped data. And what kind of frequency distribution is this? This is discrete distribution because you can see that we have not taken any intervals. Instead, we have taken only individual values. Okay, so let us take another question to further understand the method, right? Now this question says that we have to form a discrete frequency distribution that is taking individual data points from the following scores. So these are scores of some kind. Okay, so we have to form a frequency distribution table. You can write the name of the table as frequency distribution for scores or anything like that, right? So let us take this raw data and start counting the data points. Okay, so after seeing the data points, we find that the smallest data is, I think, 15, right? So we can start variate. What is variate? Variate means the scores. Okay, in the previous question it was age, right? So 15. Now the next data point should be 16. Do we have 17? We do not have 17. So the next data point is 18. Right. Now this is the problem. This is the actual problem with this frequency distribution, discrete frequency distribution, because see, we have to see. Now they have skipped 17 and we are searching for it. So it is wasting our time. That is why we start using grouped frequency distribution, right? So let us complete this table. After 18, do we have 19? No, we have directly 20. Okay, after 20, we do not have 21, 22 or 23 also. We have 24. Then we do have 25. Do we have 26? No, we have 27 directly. Then 28 is there. And I've seen 29 also. Okay, so 29 is there. And the last one is 30. Okay, so how many data points? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are total 10 rows because there are 10 different kind of data points. Now let us count these, right? So 15, 1, then 15, 2, then we have 15, 3, and then 4. So yes, 4. So the frequency of 15 is 4, right? Let us start counting. 16, 1, then 2, then 3. Similarly, we have 4, 5, and then 6. So this is 1, 2, 3, 4, 5, and this one is 6, right? Then we have 18. So 1, 2, 3, 4, 5, and 6. So 1, 2, 3, 4, 5, and 6, right? Then we have 20. 1, 2, 3, 4, 5. Okay, so we have 20 only 5 times, right? No, it is 6 times. 1, 2, 3, 3 in the upper line and 3 in the second line. Okay, so 6. So in this way you can commit some mistakes, right, while counting. So you should be very careful. 24, 1, 2, 3, and we have 4, 5. So 24 is 5 times. 3, 4, 5, right? Then we should count 27. 1, 2, 3. So 27 is, I think, 3 times. Okay, we have skipped 25. Let me see 25. So 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. So it's 25. Then we can see 28. Let us see 28. 1, 2, 3. So 28 is also 3 times. Then let us see 29. 29 is not on the upper line. 1. Okay, only 1 time. Then we could see 30. 30 is also, I think, 1 time only, right? So now again the total should be how much? The number of scores. So okay, it was not given in the question, so let us count. 4 plus 6, 10 plus 6, 16 plus 6, 22 plus 5, 27 plus 5, 32, and 3, 35, then 38, 39, 40. So we have total 40 different data points. So again, this was the required discrete frequency distribution for the given scores, right? So in this way you could construct a discrete frequency distribution in which you should have only 3 columns in the table. The first column should be the variate, it can be marks, age, anything. Second should be a telemarks, it is same, and third should be frequency, it is the number of students, it can be anything. Okay, the number of times the data point is repeated. So you could simply write frequency, you can give a suitable title like the number of students and okay, or number of books, etc. So these are the ways in which you could confirm you could construct a frequency distribution, right? Frequency distribution of ungrouped data, and this data is discrete, right? We have not taken any intervals. Now let us see, because this data is not of much use. This type of table is very cumbersome and time consuming, so it has its own limitations, because if the range of data is high, we have to add. You can see in both the questions, in the first question we only have to make 4 rows. Here we have to dedicate 10 different rows. Now if the data points were large, we could have to expand our table. Now it would be actually against the reason that why we started tabulating the data, so as to make it easy, but it is again containing your time. So due to these limitations, we shifted towards construction of grouped frequency distribution. So let us see how do we construct a grouped frequency distribution with the help of this question. So the question is simple. It says that water tax bills in rupees of 30 houses in a locality are given below. Construct a grouped frequency distribution with class size of 10. Now what is class size? It is indicating that you have to take the class size, that is the lower and difference of lower and upper values in a class, to be 10, right? So let us start. Now the raw data is given like this. So for constructing a frequency distribution, we first have to identify that what is the maximum data and the minimum data. So here maximum value of, you can call them as variates, right? These are what, just variates. Maximum value of variate is equals to, let us see, we have 112. Let us see if we have anything higher than 112. No. So we have 112 as the maximum value. Let us check the minimum value. So minimum value of variate is equals to, we have 30 and we have 14 and 15. Okay, so 14 I think is the minimum value, right? So this is the minimum value. Then the second thing which we have to do is, that is the first thing. The second thing which we should do is we have to find the range. Now because that is why we are using this particular frequency distribution, right? Because it can be used for high range. So range is what? Maximum value minus minimum value, that is this. So the range of data is 98, right? Now how many class intervals do we have to make? The size of interval should be 10. It is given in the question. So how many intervals? Now you have to represent this range into different intervals. So class size is 10. So formula for that is, okay, we should calculate, imply set range. Okay, so we have to distribute this range over these class intervals. So how many class intervals? Let us divide it by the class size. We will get the number of intervals, right? So range upon class size is actually 98 upon 10, which is equals to 9.8. So 9.8 is closer to 10. So we have to take 10 different intervals. Okay, each interval should have class size of 10. So to represent a data with range 98, we have to take 10 different intervals. Okay. So in this way, we can identify the minimum maximum value. Second thing should be range, and then we have to identify how many intervals we have to make, because that much will be the number of rows you have to dedicate in the table. Okay, so class size upon range upon class size is 9.8. So we should have 10 classes. Okay, so we should have 10 classes, because we can't have 9.8 classes. So we should have 10 classes, each of size 10, because it is given in the question that we have to make the class size of 10, right? So we have to make 10 classes. Now these 10 classes should include the minimum and maximum value. So from where they should start? They should start from the point where they can include the minimum value, which was 14, and they can include maximum value, which was 112, right? So simple. The first class can be taken as can be taken as 14 to 24, comma, as it includes the minimum value, as it includes minimum value 14, and last class can be from 14 to 24. The 10 classes would end at 104. So last class can be 104 to 114, comma, as it includes as it includes maximum value 112, right? So the first class can be taken as 14 to 24 as it includes minimum value 14, and the last class can be 104 to 114 as it includes maximum value 112, right? So in this way you can make the classes. Now since the classes are continuous from 14 to 24, then the next class will be from 24 to 34. So you could choose either the exclusive method or the inclusive method. Let us, in this particular question, let us choose the exclusive method, right? So let us make the classes using exclusive method. That is, the classes would be 14 to 24, then they would start from 24 to 34. So clearly the next class will be 34 to 44 and so on till 104 to 114. Now you can clearly see this 24 is repeated 2 times. So clearly the upper limit 24 would not be included in this class, and it would be included in this class 24 to 34, right? Similarly 34, that is the upper limit, will not be included in this. It will be included in 34 to 44. So that is what exclusive method. So it is your choice if you want to make from exclusive or inclusive. Let us take the exclusive method in this question and we'll see the inclusive in the next question, right? So let us construct. Now we are very ready to construct the table. So this is all we need for constructing a grouped frequency distribution table, right? So we have found the maximum minimum value, we have found the range, we have divided the range by class size, and we got the number of classes. Okay. Also, we have started forming classes with the help of exclusive method. So let us finally make the table. So this was our raw data, right? So let us form the distribution table. We already know that our table should start from 14 to 24. Then it should be 24 to 34. Then it should be 34 to 44. Then it should be 44 to 54. Then it should be 54 to 64, then 64 to 74, then 74 to 84, 84 to 94, 94 to 104, and the last one was 104 to 114. So these were the class intervals, right? So I have written in this format so that it is easy for you to understand, so they do not get messed up. Okay, but you should write in the column so as to have more space, right? So let us count them again. Now 20, you should remember that 24 is not included in this particular team. Okay, so we should avoid 24. So let us take from 14 to 24. From 14 to 24, so we have 14, 1, right? Then we have 15, 2. Then we have 23, right? And then we have 14, 4. Okay, so we have 1, 2, 3, 4. So we got 4, right? Then we should see from 24 to 34, 1 and 2, and 24 to 34. So 34 will not be included. Okay, so we have only 2 entries, so the frequency is 2. Then we should see from 34 to 44, right? So from 34 to 44, 1, 2, 44 will not be included, 3. So we have this entry. Now let us see from 44 to 54. 44 to 54, 1, 54 will not be included, 2, 3. So again 1, 2 and 3. Right. Now we should have from 54 to 64. So 54 would be included, right? 1. And then till 64 we do not have 52 to 64. Okay, so we have only 1 entry, so we can write 1. Then from 64 to 74, 64 to 74. 74 would not be included. Okay, 64, 1, 2. So we have only 2. Right. Then from 74 to 84, 1, 2, 3, 4, 5. So we have 1, 2, 3, 4 and 5. So we have frequency 5. Then from 84 to 94, right, in this way we have to count 84 to 94, 1, 2 and 3, right, so we have only 3. Then 94 to 104, 94 to 104, 1, 2, 94 to 104, so we have 1 and 2, and 94 to 104, and then this 3, and okay, so we have only 1, 2 and 3. So remaining is 104 to 114, 1, 2, 3 and 4, 1, 2, 3 and 4, right. So now this data should be equal to 30, the total should be 30, so 4 plus 2, 6, plus 3, 9, plus 3, 12, plus 1, 13, plus 2, 15, plus 5, 20, then 23, 26 and 30. Okay, so you can count them so that you can find it if you have left any of the data, right. So in this way you could construct a grouped frequency distribution table. Okay, so we have used the exclusive method, that is why we have not included the upper limit in this type of intervals. We have used the upper limit in the next interval, right. So let us take another question to form the similar table with the help of inclusive method, right. So this particular question says that form a grouped frequency distribution from the following data by inclusive method taking 4 as the magnitude of class interval. So again the class size has been given, right. Magnitude of class intervals means the class size, right. So we are given the class size, but we have to form the table using inclusive method, right. So we are choosing to form from inclusive method. That is not a compulsion. You can have exclusive method also. Even most of the students prefer exclusive method, right, because it gives a sense of continuity. So you do not have to make mistakes to write the intervals, right. So again we have to do the same thing, the minimum and maximum value. So here maximum value, we do not know what kind of data is this, so we can directly write value. So maximum value of variate is equals to, let us see the maximum value. So 31 for now, 34, 38, 38 and 36, no 38, 38. So yes, the 38 is the maximum value. Let us find the minimum value. Minimum value of variate, right. Let us find the minimum value. So we have 19, 16, 10. So we have 10 as minimum value. So do we have any single digit number less than 10? No. So yes, 10 is the minimum value. The second point was to find the range. Now let us find the range, right. Range of data is equals to maximum value, that is 38, minus minimum value, that is 10. So we will get 28. So 28 is the range of data, right. Now after taking the range of data, what we have to do is we have to find the number of classes we have to write. Now the class size is 4, so let us divide the range by class size. We'll get the number of classes. Okay, so number of classes or number of class intervals, you can call them. Okay, intervals is equals to range upon class size. Range upon class size, that is, you can have 28 upon 4, which is equals to 7, right. So that is range upon class size. So we have to make 7 classes. That means in the distribution table you have to dedicate 7 different rows, right. So it is that easy. Now we can clearly say that since we have to make 7 classes, so how do we start the classes? Okay, that is also important, from where you have to start. Then the starting point is again your choice, you can start, but try to start with the minimum value. Okay, so we already have, that is the purpose of minimum value also. There is a second purpose other than finding the range and class intervals. The second purpose is to how from where to start. Okay, so we can take here, we can take the first interval, so we can take the first interval as, now you can clearly see if you start taking from 10, now the size is 4, and if you are choosing inclusive method, then 10, 11, 12, 13, so your interval should be 10 to 13, then from 14 to 17. Okay, in this way, so you should always count that your maximum value, that is in this case it was 38, should come in the last interval. So we can take the first interval as 10 to, now again, if you are choosing inclusive method, then 10, 11, 12 and 13, right? So that should be your class size, because in this case 10, 11, 12, 13, all 4 numbers are included. That is why it is inclusive method. Had you chosen exclusive, you could have easily taken 10 to 14, because in this case also, but then you will say, so 10, 11, 12, 13 and 14, 5 numbers. No. 14 is not included. Okay, let me give you the previous example so that I can actually differentiate between exclusive and inclusive method. Clearly the class size should be 10 here, right? Now if you count from 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 and 24. So you will say, sir, the class size is 11. No, it is 10. Do you know why? Because 24 is not included. 24 is just here to maintain the continuity. That is the beauty of exclusive method. That is why I said that students sometimes prefer exclusive method. In this you can clearly see 24 minus 14 is 10. Okay, because 24 is not included, that is why class size is maintained. Now what happens in the inclusive method is, if you make the intervals as 10 to 13, if you minus you will take 13 minus 10, it will be 3, right? So you will get confused. So class size is 3. No, class size is 4, because in this case both the endpoints 13 and 10 both are included. But in exclusive, only the lower limit is included, not the upper limit. So that is the difference between exclusive and inclusive method, right? It is that easy. And if you get chance in exams, you should always go with the exclusive method, because that is less time consuming and less confusing. Okay, less time consuming and less confusing, right? So you will save time also and effort also. Okay, so the first interval can be taken as 10 to 13, and first now take 13 full stop, then using the inclusive method, comma, second interval will be what, 14 to 17, right? There will be a gap. Similarly third interval. Okay, similarly last interval will be, now you have to calculate in the rough. I have already calculated. So the last interval will be, because you have to check that if it is fitting your maximum value or not, last interval will be in this way, 38 to 41. Clearly 38 is getting fit in this particular interval, and there are only 7 intervals according to the question, right? You can make 7 intervals. Even if you want, you can make 8 intervals also, right? So all our 7 or 8 intervals will fit our values. So yes, we can make them, right? So in this way you can also, it is not the case that you only have to make the 7 intervals. If you want, if you are using inclusive method, then always remember that number of intervals will increase by 1. What am I telling is, since we have found out that the number of intervals should be 7, but that is for the exclusive one. If you are using inclusive method, then this will not be the 7th one, this will be the 8th interval. Let me show you in the table. Let us start constructing the table, because now we are ready with the intervals. So let us do that. Okay, you can clearly see 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 columns I have made. Why? Let me show you. The first interval is 10 to 13. The second interval is 14 to 17. The third interval will start from 18 to 21. Then the fourth interval will be 22 to 25. fifth interval would be 26 to 29, and the sixth interval would start from 30 and it will end at 33, and then we will have 34 to 37. Clearly the seventh interval is not including 38, right? And the last interval will be 38 to 41. So that is happened because we have chosen the inclusive method, right? That is why firstly we have calculated, then it came out to be 7 intervals, but we have got 8 intervals, right? So that is because of choosing the inclusive method. So that is the difference between both the methods. Now let us count each data point, right? From 10 to 13. So let us count 10. 1. Okay. 2, because 13 is also included in this case. 10 to 13. 2. 3. 4. 5. So we have 1, 2, 3, 4 and 5. Right. Let us see from 14 to 17. From 14 to 17, so it is 1, then 2, then 3, 4, 5, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. So it is 8. Then 18 to 21. 18 to 21. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So that is 8. Now 22 to 25. Okay. 22 to 25. So 1, 2, 3, 4, 5, 6 and 7. So 1, 2, 3, 4, 5, 6 and 7. Right. So 1, 2, 3, 4, 5, 6, 7. Now let us take 26 to 29, and we will have 26 to 29. 1, 2, 3, 4, 5. So 1, 2, 3, 4 and 5. So we have got 5 values between 26 and 29. Let us take 30 to 33. So 30 to 33 would be 1, and then we have 2, 30 to 33. No, 1, 2, then 3, 4. So we have 4, 1, 2, 3, 4. 34 to 37. 34 to 37. 1, 2. 1, 2. Then 38 to 41. So we have not left anything inside. So 1 and only 1. Right. So let us see the total. So according to the question, okay, so let us see what is the total number of data points given. 5 plus 8, it would be 13 plus 8, 21 plus 7, 28 plus 5, 33 plus 4, 37 plus 2, 39 plus 1, 40. So there are 40 data points. So in this way we have constructed the grouped frequency distribution table for the given data using the inclusive method. Okay, this time we have used inclusive. In the previous question we had used the exclusive method. Okay, let us take one more question so as to again finalize the method, right? Now in this question the data are clearly mentioned that they are marks, okay, and these are of 40 students. So marks obtained by the 40 students of class 8 in an examination are given below. So these are the marks. It says that present the data in the form of frequency distribution using the same class size. Okay, one such class being 15 to 20, where 20 is not. So see why I've chosen this question. Let me show you. This says that you have to form the frequency distribution, and since it is talking about class, so it is continuous, right? So that is not a problem. Now in the previous two questions it has directly given the class size. In this case it is not giving the class size directly. Okay, so we have to take the class size. Now we have to find that what is the class size, right? clearly from 15 to 20, if 20 is not included, then what is included? 15, 16, 17, 18, 19. So class size is 5, right? So it is directly indicating that you have to use the exclusive method. So this is the indication of two things. First of all, this shows where 20 is not included, that it is the exclusive method. Second, it shows the class size 15, 16, 17, 18, 19. These 5 values are permitted, right? So the only thing which we have to do is now is we have to find the minimum and maximum value, just to see that from where we have to start the intervals, right? So this is a very easy question, right? So we can directly have minimum value as, minimum value is 0, and since it is exam, so it cannot be less than 0. So yes, it saved you, the data type saved your time this time. Okay, so maximum value, what is the maximum value? Since it is maximum marks are not given, so we have to take it manually. 18 for now, then we have 23. Okay, then we have 24. So we have got 24 as the maximum marks. So there's no need to find the range since class intervals are already given. So we do not need to find how many intervals do we have. We just have to see the interval should include 0. So yes, they should start from 0. Okay, since 0 maximum, 0 is minimum, 24 is maximum, and 15 to 20 is one such interval. And since the classes are of equal size, according to question, comma, required, according to question, comma, required intervals are, what are the required intervals? The required intervals are from 0 to 5, then we will have 5 to 10, because we are using exclusive method, so it should be continuous. Then we will have 10 to 15, and then 15 to 20 is already given, and then we can directly have 20 to 25. That should be the last interval, because we do not need much than that. Okay, so even if you find the range of the data is 24 minus 0, which is 24, and if you divide it with the class size, that is 5, you will get 4.8. 4.8 means that you can have 5 different intervals for the exclusive one, and yes, we are having 5 intervals. So that method is also working here, which we have used in both the questions. So let us construct the table finally. So on the mark we can have the class intervals. You can also write class intervals here. Okay, marks or class interval. So it will be 0 to 5. So this is nothing but class interval, and you can have write class intervals here. So 0 to 5, then we will have 5 to 10, then we will have 10 to 15, then 15 to 20, and then finally 20 to 25. So in this way you can write the class intervals. Now let us start counting from 0 to 5. Okay, so 1, 5 will not be included. Okay, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So frequency should be 6. Then 5 to 10. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, and 9, and finally we have 10. Right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the frequency was 10. And then we will have 10 to 15. From 10 to 15, then we have 1, 2, 3, 4, 5. After 5 we have 6, then 7. 2, 3, 4, 5, 6, 7. So we have 7. Then 15 to 20. Okay, from 15 to 20 we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then from 20 to 25, 1, 2, 3, 4, 5, 6, 7, and we have finally 8. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8. Now let us see the frequency. It should be, the total should be 40. So 6 plus 10, 16, plus 7, 23, plus 9, 32, plus 8. So yes, we are 40. So in this way we have constructed the grouped frequency distribution table of the marks of 40 students in an examination of class 8th, right? So these were the constructions of both discrete and grouped frequency distribution with the help of questions, with the help of both inclusive and exclusive methods. So I hope you got my point and you understand this lecture very well. I'll see you in the next lecture. That's all for this lecture. Okay. Thank you for watching this till end. Goodbye.